Now, let's look at the sum of the first n terms of our geometric series, okay? So in order for us to get that, we need to understand that the sum of the first n terms, okay, of a geometric series with first term, of course, which is a, and common ratio, which is your r, is given by Sn is equal to a r to the power n minus 1 divided by r minus 1. This is if r is greater than 1, okay? R, we know that that's our common ratio. Or your Sn, the sum of the first terms of the geometric series, is always equal to a 1 minus r to the power n divided by 1 minus r. This is if r is less than 1. So this is how we can calculate the sum of the terms of the geometric series. Again, the proof is also examinable. You can do the proof as well so that you can get the answer in the first method. Okay. So again, if you want to know the proof, just type in the group, then we can do the proof for you. But without wasting much time now, let's go straight into understanding the few questions or few examples which you can do this. The proof is examinable, guys. It's going to be asked in the exam. Actually, let's just do it so that everyone can understand. So we know that this is a geometric sequence series, which means it has the attributes of the geometric sequence. So we know that Sn will just be equal to, what is T1 of the geometric sequence? We know that geometric sequence is equal to, Tn is equal to a Rn minus 1. So T1 will be a times r to the power 1 minus 1, which is 0. Then your a is just going to be a there. Our term 2 will be equal to a r to the power n, which is 2 minus 1, which is equal to AR. So that would be our term number 2, and term number 3 will be equal to AR to the power 3 minus a 1, and that will give us our T2 to be AR cubed. Just as we go forward, jalon. So now when you want to calculate the sum of the terms, as we say that the series is more about adding the terms which are available in the sequence. So our Sn now will be equal to, now we are doing the proof. Let's use red, let's use black. For the proof now, we know that Sn is always equal to your a plus ar plus your ar squared, because we are summing up the terms as you are seeing. So this is ar squared. So we are saying that we are summing up the terms of the sequence plus your ar to the power n minus 3 plus your ar n minus 2 plus your ar n minus 1, and this can be your equation number 1. Now equation number 2, that will be Sn again multiplied by the r, the co-ratio. So that will be your ar, start here, okay, because r times a, it's ar, r times ar, that will be plus ar squared plus ar n minus 3 plus ar n minus 2 plus ar n minus 1 plus a to the power n, and this can be equation number 2. Then now we can now be able to say equation number 2 minus equation number 1, so that our life can be nice and good. So that will be r Sn minus this equation number 1, which is Sn, will be equal to, here we see that we have nothing here, so that will be 1, that will be 0 minus a, that's negative a, okay, ar minus ar, that's 0, ar squared minus that, that's 0, this 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 minus that, then we are all left with a to the power of rn. So sorry, forgot the r there, okay, so that would be minus plus our so this is supposed to be plus ar to the power n. Yes, so that would be plus ar to the power n. Okay, because other things, they will just cancel each other, as you can see. Ar minus this, it's 0, this minus this 0, this 0, 0, 0, and we're all left with this ar to the power n. Then here 0 minus this, that's giving us that negative a. Then after that, you can see that Sn is common, so that would be r minus 1 equal to a is common, that would be negative 1 plus r to the power the power n. Then of course we need Sn to be the subject of the formula. So Sn will be equal to, we divide both sides by r minus 1, divide both sides by r minus 1. Then your Sn will be equal to a r to the power n minus 1 divided by r minus 1, and we can see this is when r is greater than 1. So this is just the proof. It's simple and straightforward, as you can see now, that this is how we can solve and get the proper answer in this specific sequence, or in this specific geometric sequence which we have. Okay, now let's just have one example there so that we can understand what we mean by that. Okay, so an example, let's say that determine the sum of the first 10 terms of the series. Okay, let's give the series, maybe let's say 3 plus 15 plus 75 plus. Okay, so we need to calculate the sum of the first 10 terms, and this is our geometric series. And we know that the geometric series, we need to understand that our equation Sn is always equal to a r to the power n minus 1 divided by r minus 1. Now what is n? N is given already, that for the first 10 terms, so that our n will be 10. Then our r is going to be the common ratio, which is t2 divided by t1, which is equal to t2 is 15, so that will be 15 divided by 3, which is equal to 5. Is it? Yes, that will be equal to 5 over there. Then after that, now we can now substitute, because we now have, and of course our a is equal to 3a is our first term of the sequence. We have our a, we have our n, we have our r. Now we can substitute into that equation. Then our Sn, then that the sum of the first 10 terms will be equal to a. Our a is 3, our r is 5 to the power of n, which is 10 minus 1, divided by r. Our r is 5 minus 1. Then after that, you use your calculator to get the sum of the first 10 terms. So those are just the small examples which you can expect to get when you're looking at the geometric series. Easy as that, then you should be able to understand further. Now perhaps let's say that you are given another series, 5 plus 10 plus 20 plus, so this is example number 2, plus 40 plus, then after that you are given the last term plus 6 5 5 3 6 0. So the same thing which we did in the previous example, we have to apply it again. We need to first calculate the n value on how many terms do we have in this specific sequence, or in this specific series which we are having here. So in other words, we need to have our tn again, which is equal to ar to the power n minus 1. What is our a? Our a is the first term, which is 5. And what is our r? Our r is always t2 divided by t1. T2 divided by T1, that will give us your R, and that will be 2 to the power n minus 1. Okay, then that will be your Tn. But now we're given the last term, which is 65, so that will be 65,500 and, okay, sorry, that's 655,360, which is equal to 5 times 2 to the power n minus 1. Then after that, we can play around with our rules of exponents. Divide both sides by 5. This and this will cancel. Then that will be 655,360 divided by 5. Then we get 131,072, which is equal to 2 to the power n minus 1. Then of course we can now have 2 to the power 17. You press your calculator to get factors, then that will be 2 to the power n minus 1. Then of course 17 is equal to n minus 1, and then therefore your n will just be equal to 17 plus 1, which is equal to 18. Now that we have the n term, now we can now calculate the sum of the nth terms of this geometric sequence. Okay, because we know already that our n should be the sum of the 18 terms, since we are given the last term. Then of course that will be sum of the 18 terms, which is equal to our a is the first term in this sequence. In this instance, it's just 5. R is given as 10 divided by 2, which is 10 divided by 5, which is 2 to the power of 18 minus 1 divided by 2 minus 1. Then again, you use your calculator or your operator there, then you get your answer. Dango means thank you. That's how we do our geometric series. Okay, please go over it. If you don't understand, just type your question on the chat box, or even on our WhatsApp group, so that you can get the understanding. Thank you.